All right, so volume equals length times width times height. All right, so we said 14.25 times 4.57 times 1.97. And I got some giant answer with a whole bunch of decimal points on my calculator. And I said to myself, I have how many significant digits here?
4.
4. How many here?
3.
How many here?
3.
So I looked at my calculator and I said, I have 128.291. Blah, blah, blah. I need how many significant digits?
3.
So I'm rounding it to what?
128.3. Wait.
All right, so I'm going to write down that first answer some of y'all yelled out. 128.3. How many significant digits does that have?
4.
Has 4. And y'all said you want how many significant digits? 3. So I'm going to round it to what again? Just round it off to 128. Okay? This is why I said the other day, I don't take off for rounding. Just drop off the numbers. Stop trying to round them. Just make them go away. Drop it off. 128. What happens when you say a centimeter times a centimeter times a centimeter? Centimeters who? Cubed. So there's your volume. Now, to find density. Density equals what formula? Mass over volume. What's the mass?
50.52 grams.
50.52 grams divided by?
128 centimeters.
Okay. So, all right, I get a whole bunch of numbers again, 0.3946875, and I just quit writing. All right, grams over centimeters cubed. Now, same thing. Look at what you have. How many significant digits in my top number? How many in the bottom number? So how many do I want in my answer? Again, I'm not grading y'all on rounding. So I'm just going to take the first 3 numbers, and I'm going to drop off the rest of them.
But we never need to round.
I'm not going to take off if you don't. If you want to, great. 0.395.
Now the final.
On what? This is not the final test. And besides that, this is all extra stuff because you're in honors. It's not on final exam. Okay? So, there's your answer. Questions?
Oh, no, I ain't gonna get it.
All right. Number 2. Can I erase? All right, so number 2. All right, we're adding. What rule do I use for adding? All right, so 23.4 plus 45.67 plus 3.012. I get 72.082. Did I add that right?
Yes.
All right, so how many places behind the decimal? Here and here. How many do I want there? You can put 72.0 or you can put 72.1. I can live with either one. Of course, 72.1 is the better answer because you should round up. However, 72.0 has the right significant digits. I am not going to mark it wrong. Questions? Okay, number 2. 14.30 times 3.01 divided by 0.035. I get 1,229.8. All right, now I need to use what rule? Significant numbers. So how many are significant here? All 4. This 0 is after the decimal and after a non-zero digit. So you can say after the 3. How many are significant here? And how many here?
2.
Only 2. So I want how many in that number? 2. So I only want these 2, right? So 2, and then again, if you had $1,229 and I rounded you down to $12, would you be happy? No. So this is one of those you need to fill in with zeros so you stay in that same place of $1,200. Okay? So $1,200 would be fine. Now, for those of us who didn't know what to do with number 3 because you're like, I don't know what to do them scientific notations. Do you remember how to punch those in on your calculator?
Yes.
Is it because you don't have a calculator at home that you don't know what to do with them at home?
No.
Okay, you do the same thing.
Are you supposed to keep it in scientific?
Keep it scientific notation.
Or like,
No, keep it scientific notation.
no,
Okay?
like the mode thing. You keep
Yeah, put it in mode, put it in sign.
Oh.
Okay, so mode,
No wonder my number-
psi, enter, clear. It's in scientific notation. Okay?
Yeah.
So 3.45 second EE 5.
Forget the E.
Don't hit times or anything else. Just hit 3.45 second EE. And then the E pops up and you tell it 5. All right, this is the times because there's nothing else there but parentheses. 4.3 second EE. And then the E comes up and I say -8. Yep, this exponent's -8. You don't hit times 10. You don't hit the times, you don't hit the 10. Okay? But when you hit second and then that EE key, the E comes up on the calculator.
The E. Yeah.
Did you forget the EE key?
Yeah, I just put times 10 and then the E.
No.
And then-
No, don't hit times 10. You hit second and the EE right there. And that E pops up. You never hit the times or the 10. Okay? Now, when you do that, I get 1.4835 times 10 to the -2nd. Now I use the same rules I've always used. Am I multiplying and dividing or am I adding and subtracting? I'm multiplying and dividing, right? So when I use my rule, this has how many significant digits? And this has, so I only want, so I'm keeping the first two. 1.4 times 10 to the -2nd, or if you feel like rounding, 1.5 times 10 to the -2nd. Either one is fine. Either one is acceptable. But if you don't round up, I'm not going to mark it wrong. Or if I accidentally do, I'll give your points back. Now, if you get crazy and change that to like 1.9 times 10 to the -2nd, yeah, I'm usually going to mark that wrong. Or, 2.0, I'm going to mark that wrong. A little rounding is okay. Don't get crazy. It's what? Well, I can't fix that. You got to do it on your own sometimes. All right, can we talk on mark?
Yes.
All right, let's see how you did with that.
Okay. I didn't get all that together.
All right, question 1. You could have left it at 31, or you could have rounded it up to 32. Either one would be okay. But you don't want any places behind the decimal there. You're adding, so no places behind the decimal. So drop off all the places. So either leave it at 31 or round it up to 32 if you wanted to round. Number 2, you need one place behind the decimal. So you could have left it at 84.6, or if you felt like rounding, you could have changed it to 84.7 if you wanted to round it up.
So wait, they would go for number 1. They would go decimal point 0, so 0.1.
You can't put a 0 there because that would have put a decimal point there. You got to drop it all off. Just 32 or just 31. But you can't put 0.0 because that puts a decimal place there. So, yes, it is adding. You have, maybe I have the wrong worksheet.
I got 31.9.
You told my number 2. I got 31.88.
I got the wrong
Yeah,
worksheet.
I rounded up to 31.9.
I got 31.88. I got run.
How many places behind the decimal?
1,
Here,
2,
here.
0.
We can't have any places behind the decimal. So these have to go. Okay? So 31 is all we get to keep. So you can leave your answer at 31, or if you felt like it, that 8 can round that up to 32. I will take either answer, either 31, or I will take 32 if you round it up. But I cannot take something that has a decimal behind it. So if you write 31.0 or 32.0, these have decimal places behind them. They're wrong. Okay? You with me on that?
Yes.
Okay. Number 2. Somebody pointed out I'm subtracting. Yes, I am. There's a subtract sign there. 84.68. How many places behind the decimal?
No.
How many here? I want 1 in my answer. So this is what I'm keeping. If rounding bothers you, don't round it off. 84.6. I'm good with that answer. I am not going to mark it wrong if you round wrong. Drop off the 8. You've got your significant digits right. That's what I'm grading. I'm not grading your math skills and your ability to round. If you suck at that right now, I don't care. Okay? That's your elementary school teacher's problem. I'm not reteaching rounding. Okay? I'm grading your significant digits. Can you follow the rules? Can you tell me that you're only supposed to have 1 place behind the decimal? If you can get that part, I'm all good. Okay? Number 3, we're multiplying. 147.8 times 0.0065. You get an answer of 0.9607. How am I rounding it? How many significant digits are here? How many are here?
2.
How many I want there?
2.
I'm only keeping that. I can write 0.96 or I can write 0.96. Either one would be good because that first 0 is what?
Billboard.
It's a billboard. It's not significant. It doesn't matter. Either one of those are good.
What if there wasn't?
Like it's not there?
Yeah.
It's good. That's why I said this one's fine. You don't have to have it. So you can leave it off. Okay? Number 4, you only have 1 significant digit there and you're dividing. So your answer can only have 1 significant digit. I rounded mine to 200. If you rounded down to 100, I would take it. Okay? You get 171. But 171 has how many significant digits? Can't have 3. You can only have 1. So I rounded up to 200. You could round down to 100. Did everybody put in scientific notation, say 2 times 10 to the second? That would be okay too if you tried that. Number 5, you need 3 significant digits. So I rounded off to 10.4. All right, number 6, several of you said, I ain't gonna do this. All right, so I punched it in my calculator. 1.45 times 10 to the 5th plus looks terrible, plus 6.854 times 10 to the 5th. You use those 10 to the 5th, that second EE. Once you do, you get 8.304 times 10 to the 5th. How many places behind the decimal are here? How many places are behind the decimal here? So what's the least number? I'm keeping these 2 right here. So I'm rounded to 8.30 times 10 to the 5th.
That's still there. Oh my God. Oh wait, wrong problem.
I'm just looking at this.
So, but I got this. Do we focus on the middle operation as an addition and subtraction?
Yes. Yes. So like here, this is the scientific notation piece. So don't worry about that being your operation. You're looking right here, Queen, to see what they're asking you to do. And they're asking you to add there. Okay? So like in the next one, they're asking you to do what? In number 7.
Divide.
They're asking you to divide. So if you're dividing, you have 2.015 times 10 to the 12th divided by 5.2 times 10 to the 6th. So again, what rule are we going to use? Significant digits. So how many significant digits are here?
4.
And how many are here? 2. So when we divide, we get an answer of 3.875 times 10 to the 5th. So how many am I keeping in my answer? So I'm just going to keep these and go with 3.8 times 10 to the 5th. Or if you felt so led and wanted to round up, you could say 3.9 times 10 to the 5th. But again, I am fine if you leave it at 3.8. I'm not going to get upset by that. Number 7, you're adding.
I get 3.8.
Whoops, I jumped one. Say what?
I get 3.8. Oh, yeah, that's-
On the calculator? All right, I said you don't have to put the parentheses.
Oh, I do got that. Yeah, I'm looking at my phone.
Oh. All right, number 8, you get, I got a really big number here, so you can do it either way. I got,
Wait, what? Okay, 1 minute. Oh,
Yeah, I got
yeah.
that.
you can leave it like that and then change it to 1, 7 and fill in like this if you prefer, or you can round if you prefer to round. I hate all those zeros, so I personally would change it to scientific notation.
So,
But if you don't want to, you don't have to.
did you count it as?
I would take any of those 4 answers.
Oh.
Any of them would be fine.
I got this.
So what?
So you want to take that one?
Oh, Jesus.
I told you last week you had one today.
So you
What?
want to take the
Oh,
first
I
one?
did.
Okay.
The first one is a no. This one is no because that has 3 significant digits, and you have to have how many? 2, because you only have 2 significant digits in that 0.0020. Anything that's boxed in, any of those 4, I would take because those all have 2 significant digits. Number 9, 58.971, I would take, or 58.970 because you need 3 places behind the decimal. All right, you get an answer of 58.9705, and you need 3 places behind the decimal. So you need that. So I would take this if you don't round up, or I would take this if you do round up. So I would take either of those for number 9. I would take either one because you need 3 places behind the decimal. Number 10, you need 3 significant digits. So 4.32 times 10 to the 11th, or 4.31 times 10 to the 11th.
You have to put the parentheses.
No, you do not have to put
I'm like, you
parentheses
give different answers. I'm like, oh.
because you're punching the calculator wrong.
No, like, I would look over it multiple times.
Punch it in the calculator and do not hit erase and let me see it. All right.
Did you move the decimal pad?
Did I do what?
Move the decimal.
There?
Yeah.
No. What do you have?
I had 5.8.
Times 10 to the first? Then your answer is correct. Yours is just in scientific notation.
Oh, okay.
All right. The thing I would tell you on the quiz today, Ashaya, is there's going to be 7 questions that are not in scientific notation. Don't do those in scientific notation. The 3 at the bottom that are in scientific notation, do those in scientific notation.
Okay.
Okay? So half of your answers are in scientific notation and the other half are not. Only do the ones that are like this. Don't put these in scientific notation. So like this question that we're looking at right here, number 9, see how it's not in scientific notation? Don't do that in scientific notation. Put that in normal mode on your calculator and then change it back to scientific notation to do number 10. Okay? Number 11, either 15 or 16. If you round it up, it would be 16. If you didn't, it would be 15. Number 12, 140. Number 13, either 0.02, 0.02. If you didn't round, 0.01, 0.01. If you wanted to put it in scientific notation, I would take any one of those for number 13 and give you credit.
What was 10?
Number 10 was 4.31 times 10 to the 11th. But I would take any one of those varieties for number 13. So if you have anything that is that, I would take it on number 11. Whoops, wrong one. Number 13.
13.
How did I do it?
Yeah.
Because you have 0.006 times 3.000. You have 1 significant digit and 4 significant digits. So when I calculated, I get this. So I can only have 1 significant digit. So this is my significant digit right there. okay? Which is why I rounded this up in my first answer, okay? This is a placeholder, so it's not significant. So the 1, I rounded up to a 2, which is what I did initially, okay? But I told y'all you didn't have to round, which is why I said I'd take that, okay? So this and that are the first 2. This is, hey, there's a decimal behind me. So I said, if you want to put that there, it's fine. And these 2 I just threw out there in case you put it in scientific notation. And the last one, number 14, is 7.77 times 10 to the 14th. Anybody have a question?
Repeat that again.
7.77 times 10 to the 14th.
What was
10 was 4.31 times 10 to the 11th. Yep.
So you said what?
Shh, hold on, let Alexis finish. Which one? 140? You can only have 2 significant digits. So you got 140. Yep. As long as you take that decimal off, that's an understood decimal point, so that 0 is not significant. If you write the decimal, it is significant. Gotcha. So you put decimal places there. Don't mix those up today. Okay? Anybody else? I heard a question over here when she was trying to ask.
Oh, I didn't hear that. My bad.
Okay, so what was the question?
7, you said put it in normal. Not that one.
Number 7 is in scientific notation. So,
No, I'm making.
Oh.
Quiz, you said put it in
yeah, 1 through 7 are like questions 1, 2, and 3 on this paper. See how they're not in scientific notation?
normal.
Okay, so leave those in normal notation. 8, 9, and 10 are separate at the bottom, and they're in scientific notation. So put those questions in your scientific notation mode and calculate those in scientific notation. The directions tell you this on the quiz, to do those answers in scientific notation. So do those in scientific mode.
On quiz, are you also looking for like the?
Significant digits.
Yeah.
Yes, that's the way the quiz is being graded.
Okay.
I mean, if the significant digits are wrong, the answer's wrong. There's no partial credit on this one. You have to get the significant digits right, along with calculating it right. I mean, if you multiply it wrong on the calculator, it's wrong. So I would tell you to calculate it twice to make sure you did it right. Okay?
So if there's 3 numbers behind the decimal, you count all that? Like 3.30?
Yeah.
You count all that?
Yes. Now, if you don't round it up, I'm not going to take off for it as long as your significant digits are right. So if it can be like 7.458, and you put 7.457 instead of rounding it to an 8, I'm going to be fine with that as long as you have the right significant digits. Now, if it's supposed to be 458 and you changed it to 7, 8, 12 or something weird, yeah, I'm not going to take that. I mean, it needs to be close to what it's supposed to be. You can't just round it to some weird number just to change it.
Watch
Yeah. You'd be surprised how often I get that. All right, put your names on it for me, please. Calculate. Round the correct significant digits.
I got this.
I hope so.
As long as they are okay.
Yeah, she's fine. We have graduated from wearing a back brace, and we do not have to go back to the scoliosis doctor after 5 years. Thank God. All right, does everybody have the quiz paper? Can everybody see 1 through 7? I'll give you 2. In 1 through 7, you can see it's in normal notation. Calculate 1 through 7 in normal notation.
Hold on, I'm confused.
These are in normal notation. Do not
Oh, wait.
put 1 through 7 in scientific notation. Okay? Leave them in normal notation. 8, 9, and 10. You see how they're in scientific notation? The answers need to be in scientific notation for 8, 9, and 10 only. Does everybody understand that? Okay.
You have to.
I'm not sure. All these questions, I'm beginning to wonder. I'm very clear on what
I
I'm.
just can't read.
Okay. Have a question.
Not anymore, but
Okay. I'm just gonna be back there with your computer card, taking up computer numbers. If you have a question, I'll come back. And you don't have unlimited time, so work quick. Hey, who in here has 8A B day classes? Is it 8A or B day? There you go.
You're welcome.
So what they want?
Maybe.
That's supposed to be B day.
It is, but then he said, hey, because he asked again, because he was before. So if he thinks it's taking now, it's okay.
Tell me what day it is. Who's still working? Got a couple more minutes. How many are still working now? All right, guys, from the front. I'll still try these stupid lab numbers now.
Oh, yeah, right
All right, I will grade these and have them for you tomorrow. All right, let us switch gears and talk about heat and temperature. So find your notes. And you'll get a chance to do a lab again this week. It just won't be the one you were going to do Friday. That one is gone.
Ordered them online.
All right, we're going to talk about the differences between temperature and heat because we're going to talk about chemical and physical properties. We're going to talk about chemical and physical change, and we're going to talk about chemical and physical reactions this semester. Now, part of what we're doing the next 2 days is really not my curriculum either. It's another science teacher's, but I have found over my vast years of experience that y'all don't know this stuff, so I still teach it. Now, temperature and heat, we could argue over where you should have learned this in the middle school, but over the years I have found that some of you have had great middle school experiences. Some of you got a sub for the entire year, and so I don't even know who had the sub. But because some of you got a sub for the entire year, it's just easier to hit some of the highlights of what you should have gotten rather than assuming that you all had fabulous experiences. Now, temperature is basically a measure of a sample's average kinetic energy. Now, and I shortened this definition instead of writing the full definition out because it can be rather lengthy and we're behind. Now, if we're talking about average kinetic energy, first of all, even if you had a really crappy experience in middle school, everybody can usually tell me what kinetic energy is. What is kinetic energy? See? Now, everybody remembers that this is energy of motion. So when we consider, okay, when we're talking about something like a cup of coffee, cup of tea, something that's warm, most people can tell me that the particles in this are moving. Now, nobody has any trouble with that concept, okay? But when we consider something like a chair, all right, the particles are moving here also. No, okay? That's the piece that is harder for students to get. When we talk about the desk and the chair that you're currently sitting in, people go, Ms. Wall, it's a solid. Those particles aren't moving. Yes, they are, okay? Now, here, the particles vibrate, okay? Their temperature is going to be much lower. When we talk about the particles in the coffee cup or the tea cup or whatever, those particles are able to move freely about the cup. They're moving much faster. Their average kinetic energy is much higher. If we put the thermometer in there, the little red liquid or green liquid, whichever color thermometer you have, is going to shoot up the thermometer very, very quickly because the kinetic energy of that liquid is going to transfer to the thermometer very rapidly. Now, the chair is not going to move as quickly, and so it's not going to change very much at all. The reason is those particles cannot move as quickly. The particles that are touching the chair and the thermometer bump up against it much slower, and it's not going to move as quickly. Now, but the particles are moving. They do have a temperature because they do have an average kinetic energy. Now, before we talk about how that's different from heat, which is the concept we want to talk about today, what things do we already know about temperature? Now, everybody knows this. First of all, what piece of equipment do we use to measure temperature?
Thermometer.
All right. And if you have trouble spelling it, it's just thermo and meter. Okay, thermo and then meter, so you don't have to spell it wrong the rest of your life. Now, the units that we use for temperature are Celsius, Fahrenheit, and a lot of you know from the other day that the SI unit is Kelvin. Now, all of our calculations this semester have to be in Kelvin, with the exception of the formula that we're going to learn today. The formula that we're going to learn today can be done in Celsius or Kelvin. All right? Now, we're going to learn, or really use, two formulas today. One of them I'm going to let you write on your blue sheets. So if you will, get out your blue reference tables. Now, the first formula that I'm going to let you write on there, because again, it's an extra. It's not something you're ever going to be asked to do on the exam, but it's one that every chemistry student should be able to use because, again, it's just an algebra 1 skill. It's not anything special. So if you turn to page 3, and you make a note to write it down on your book when you get home, okay? Since you left your notebook at home. If you'll find, I think it's on page 3 or 4, you should find the formula page. The first formula is not very far down the page, I don't think. All right, it's the second one. All right, K equals C plus 273. The state has actually shortened this formula. It used to be 273.15. And because that 0.15 never changed anything when we would add or subtract, the state has taken off the 0.15. So if you take college chemistry or you're looking at chemistry textbook, it'll probably still have the 0.15 on there, but don't let it bother you. The state's just taking it off. The one I want you to write on there is C equals 5/9, F minus 32. Okay? That is how you change Fahrenheit to Celsius. And I want you to be able to do that, okay, without using the app on your phone.
Where do we write that?
Any place you want to. Most people usually write it at the bottom because it's one of the only things I'll let you add to it. Okay? See, I don't care if you write it at the top, just somewhere on the paper. So if you should see it on the test, you can access it and go, oh, yeah, I remember that formula. Because if you come to me on test day and say, Ms. Wall, what's the formula? I'm going to tell you, I don't know. So if you don't write it down, you're out of luck. Unless you just remember it. Some people do remember it. But when you ask me questions about content during the test, my answer is usually going to be, I don't know or I don't remember.
Well, I don't care.
Usually I'll save that one for during class. Okay? So if I ask you, if we go to, I don't know, let's just say we go to Brazil and the temperature is going to be 16 degrees Celsius. Would you know how to dress for the day?
No.
Okay? I probably wouldn't either. I wouldn't know if I'd need a coat or not. Some of y'all might know. Some of you might be from another country and are very familiar with Celsius. I wouldn't know if I'd need shorts, jeans, or a jacket. I'd probably be like, crap, what do I wear? So I'd pull out the handy-dandy little phone and use my app. But let's just say that we're from Miss Wall's time when we didn't have cell phones. So we had to do it the old-fashioned way. All right? I know, my kids are always stunned when I say, what do you mean you didn't have a cell phone? I'm like, we didn't have cell phones back when I was a teenager. Those were unheard of concepts. So, if I asked you to plug this in, could you do that for me? Find me the answer. Find me the answer. I didn't say do it in your head, Danielle. You can use the calculator.
It's too far.
Okay.
Oh, Emma's the phone. Clear. It's okay, Emma. I
Okay.
appreciate you.
It's early in the day yet.
Oh, here's me.
Find me an answer.
There's 20 numbers.
And aren't there like, two components? The one converted to
I'll
Fahrenheit,
think you just
and the one
write it.
converted to Celsius?
Yes, you could flip it into the other one.
All right.
But I'm not giving you both formulas. I think that's stupid. Just use one, do it one direction or the other.
Sure.
Let's go, let's go.
I don't remember on here. I'm like,
Yes.
it's either acre size or where it's somewhere, I don't know.
16 times 9.
Oh, I think I know what the units. Oh, I know what the units are.
Hmm?
I think I know what
Let me
it
do
is.
it.
All right, what'd you get?
It's either 60 or 61.
Okay.
60.8.
Okay, that's 60, 61.
Too cold.
Yeah, get it.
I could work with that.
You know,
That's warmer than this morning.
I know, I don't want to cold.
That's about what it was when I left the house this morning.
What would it be doing today?
Yes, it was.
Now, is there anyone who didn't get it?
I don't know. It's something.
I don't know.
All right, so if you're one of those folks who are like, Ms. Wall, I can't do it.
Oh.
For those of you who are struggling, get rid of your fraction.
Multiply by 9.
Multiply by 9. 16 times 9, and you get 144. Equals 5. You don't have to do it this way. This is just for the math challenged people who are like Ms. Wall. I can do this. Okay? Get rid of your fraction. Now, once your fraction's gone, now it's a whole lot easier. You've got options. You can either choose to divide by the 5, or you can distribute the 5. Which one do you like better?
Distribute.
Distribute.
No, why are you so
You guys act-
You can go ahead and do that if you
I
want.
love that.
It's not my choice, but go ahead. All right.
Then you add 160
Plus one.
and divide by 5.
Oh.
They distributed. Make sure I did that right in my head. I did. All right, so now I've got to do what to get F by itself?
Add 160.
144 plus 160. So we get 304
Divide.
equals 5F. And then what am I going to do to get F by itself?
Divide.
Divide by 5.
Which I don't get it.
So F is 60.8 degrees Fahrenheit.
I put 60.7.
That's fine. It's close enough. Everybody okay with that?
Yeah.
Now, suppose, you got it, Storia? Suppose I said something like you had 45, suppose I had 145 Kelvin, and I wanted you to change it to degrees Celsius. Everybody okay with what formula to use for that?
Yeah, sounds like,
I got you.
What formula would I use for that one?
Celsius.
K equals
273
equals
270.
All right, where would I put the 145?
At the K.
At the K, because this says K on it, right? Equals C plus 273.
Oh, I should probably break this down.
All right, how would I solve for the C?
Subtract
Subtract 273.
Everybody okay with that formula?
Yeah.
I just sort of always assume everybody's okay with that. In some years, I'm good with that assumption, and some years I'm not. So I got a negative 128 degrees Celsius is my C. Now, did everybody notice that in both of these, when I wrote C on this side, I put a unit on this answer. And if I flip back over here, when we had F, I still wrote a unit on my answer. This is the variable. It's not a unit. So when I was over here, this is a variable. It's not a unit. I got to put a unit on my answer. Did everybody notice I did that? Okay. Make sure you do that.
There were no units on the quiz, right?
No, there were no units on the quiz. Those were just numbers. Calculate significant digits. There were no units on this quiz. Okay? Now, temperature is the easier of the two in terms of calculations. Heat's got a formula we have to learn. Everybody good? Okay. Now, heat is the new concept. I would be well, they might have taught it in middle school. I teach it in physical science. Heat is a measure of the sum total of all the kinetic energy of all the particles in a sample of matter. Okay, it's a measure of the sum total of all the kinetic energy of all the particles in a sample of matter.
That's crazy how you just do that off the top of your head.
What is?
I would probably like, just like, I don't know, simplify it.
I don't have enough commitment to be a teacher.
Yeah, I don't either.
I don't feel like going to school today. I'm just not gonna go. But
I mean,
it doesn't work
it's your
like that.
job.
But
I mean, but
I feel like it
Yeah,
requires
do
too much
kids all
effort.
day.
I'm all about no effort.
I can really handle
Work with some
myself.
kids.
I like to eat. I also want to retire.
True.
When do you retire?
You want
Have to do 4 years,
Or
possibly only 3.
Yeah, 3 years ago.
4 is the max I have to go, possibly only 3. I have 200 plus sick days at the moment, so it's very possible I can go out in 3.
Wait, so Mr. Mahoney's taking longer than you?
Possible.
Mr. Mahoney's been taking longer than you?
Who?
Mr. Mahoney?
Mr. Mahoney has not been here longer than me.
Oh, then he retired this year.
He has more years because he's brought in years from working out in industry and other areas. So he's gonna have that.
I don't understand how
Is it Miss
retirement
Klein,
works.
they always?
Ms. Klein has been in the school system longer than I have, but I've been here at the high school 1 year longer than she has. Ms. Klein almost retired this summer. She was, and I'd love to know why she did not. All right. Now, what is the difference between heat and temperature? It's the key difference. All right. Heat is about the sum, okay? The sum total. So we're adding for heat, okay? And for temperature, we're doing what? We're taking a
Samples of average.
average, okay? We're just averaging the particles. So, as an example, to illustrate this, you're gonna have to work with my terrible artwork here. All right,
That mug, that was actually pretty light.
that's about the only thing I can draw.
Let's show 'em.
So we'll draw it again.
For y'all teachers, do y'all sick days matter?
Oh yeah, they matter.
Cause that's what Miss Klein was talking about.
Oh yeah,
When she was on.
Miss Klein's got a lot more sick days
She
than I
has
have.
like 2
Klein
years
is
worth of sick days.
always here. Like
That's why she said if she's sick, she still be in school.
Okay, so
I have
last
this
year,
many.
she told us
What
that
is
she was
that?
never absent. She was never
Yeah.
sick, and then she was off like 2 days.
Right. No, she go
That
for a
was the
week.
most. She probably ever.
If Miss Klein is out, Miss Klein is sick. If I'm out, I am sick. I missed 2 days. Wasn't last year, it was the year before. I had strep throat. I thought I had been hit by a bus. I drove my kids to school and my kids were like, Mom, are you okay? Are we gonna make it there safely? I was like, it was awful. I should never have driven my kids to school.
I can't live this long.
Yeah.
It was bad.
Is that trampoline?
Oh, it's a person.
Best I can do. All right, that's supposed to be a tub. All right, so we got a tub, we got a coffee cup.
Maybe that's not a mug. Yeah.
All right, so which has more heat?
Mug. Oh, why didn't you look at it?
Yeah.
No, the tub
Tub, because it has
because humans
multiple.
have temperature and the water has temperature, so you add the two together.
Ah, that was pretty
Dang, way
good.
smart.
Oh,
Is that true? No, it,
Oh, more surface area in the tub.
I need a little more.
no.
I don't know that.
Not necessarily wrong. You're going in the right direction.
You're
The water
swimming and
has
your
kinetic
particles are
energy. And
All right, let me take the person out. All right, because the person's muddling our answer.
Is the shower on?
No.
Is there water in there?
No, the.
Yeah, there's water in there. I tried to draw a little squiggly
What
line.
temperature?
It's
Is
temperature.
All right.
Depend on the
it hot
temperature.
water? Because I bathe in hot water.
All right, I don't care what temperature you turn the water on. All right, some of us take hotter showers or hotter baths than others, but generally speaking, no one is putting boiling water in the bathtub unless you want your skin to come off. Most of us are going to use either boiling or pretty close to boiling water, whether it's a Keurig machine or whether it's plain old hot water on the stove to make tea, coffee, whatever hot drink that we're making. Okay? So everybody in here at some point's made coffee, tea, hot chocolate, something to go in a mug. And everybody in here has had a shower or a bath at some point. If you haven't, please exit my classroom soon. All right? Now, all right? Think about the temperature of the water. Think about this. Which one has more heat based on the scenarios?
Measure
The
most.
mug.
Most people go that route because you're thinking about which one's hotter. It's not about
But the
hotter.
mug has more.
Yeah, Todd has.
All right.
So there's more stuff to add together, so you get a
All
higher.
right. The tub has more heat. Now, the reason I took the body out, all right, is it's got nothing to do with the body. All right. It's all about more particles. It's not about the surface area. Okay. When we said a measure of the sum total, okay, because there are more particles, the more particles add together
So this is like a chair.
to give more heat.
So even you could go with like a mug of coffee versus like the ocean in the winter. Would the ocean still have more heat because there's
Exactly.
more-
It doesn't make any difference. You could have a frozen lake, and the frozen lake is going to have more heat than a mug of coffee because it's mammoth. It has so many more particles than that coffee.
So you shouldn't think of it as being hot, but being
It's just about
Wow.
size.
okay. So how much more hot or cold?
See, that makes sense.
Most people think heat has to do with warmth. Heat is not about warmth. Heat is about
Okay,
size.
The temperature is about warmth. The heat is okay.
Yep. Okay.
I won't take them.
So when we talk, does everybody have their one off this board?
Yes.
All right, so when I teach this in physical science, temperature is about motion. Heat is about size. Okay? So if we were comparing something like a swimming pool this time of year in the South, a swimming pool in the South is very warm. If we compared it to a frozen lake versus a swimming pool, most people would want to go, oh, a lake, that's frozen. That's not got much heat at all, right? But think about the size of a lake compared to the size of a little swimming pool. Which one has more particles?
The lake.
The lake. Even though it's frozen and those particles are barely moving, there are so many more particles than a swimming pool. That frozen lake is going to have more heat than that poor itty bitty sized swimming pool.
So is it actually warm? So,
And we're not talking about warmer.
I know, but like,
We're saying it has more heat. Okay? So y'all are getting confused with warm and cold. Warm and cold isn't a description for anything. For example, if I put your hand in something that you perceived as warm, okay? And then I put your hand over there in that cold water that you say is cold coming out of that faucet, and you're going, wow, that water's cold, but this water's warm. And then I took this cold hand, supposedly, and I put it in something else that was colder, and then I took this warm hand and I put it in that water that was so cold. You're going to tell me, oh, that's warm compared to this hand that I stuck in cold ice water. Okay, so it's all relative when you talk warm and cold. All right, so it's a matter of what you get used to. Some of y'all in here right now are thinking, man, it's cold in here. Okay, I'm hot.
so nice.
I think it's hot. Most people come in here and they're like, can't you turn the heat up in here? I think it's cold or warm most of the day. Now, this Thornhill side of the building, now that's a little chilly. Even with all my heat that I have going on, I think it's a little cold on her side of the building. Generally speaking, heavy sized people, we have a whole lot of size. We have a whole lot of heat going on. So we don't get as cold in the building. Y'all skinny people, I'm going to tell y'all. My coat.
Oh my God.
Because I'm never going to ask to have the air conditioner cut down in here. So, what equipment do we use to find heat? We're going to do this later in the semester because we're going to come back. It's seriously jacked up spelling. All right, we're going to use a calorimeter. It's a lovely, expensive piece of equipment that's insulated, has holes for a No, you can't. It has some holes for the thermometer and everything else. But in deference to poor Daniela, who can't, we're going to substitute this for something she can touch later. We're going to use a styrofoam cup. You know, because we're a poor school and we can't afford real calorimeters, so we're just going to go to Food Line and buy some styrofoam cups. Okay? The units we're going to use are joules, which is the SI unit, and it's not pronounced jowls. It's pronounced joules, like jewelry.
Oh, wait.
Or-
Measure energy joules, right? So is heat just a measure of the total energy?
Yeah. It is. And the English unit is calories. Okay? She got some skills over there. Guess I'm not a science girl. All right, and calories are, yes. Yes. Okay. We thought she was making an announcement in a subtle way over there. I thought she was just making a subtle announcement. Just kidding. All right. Y'all are slow with it. They're just beginning to get it over there. Calories is, calories are English. Joules are SI.
So technically, could we say we're burning joules?
You could.
Oh, that's.
They gonna be on the test?
It's like dumb.
Say what?
That sounds better.
Yeah, they'll all be on the test.
Alright.
Our formula is Q equals M CP delta T. Q equals M CP delta T is our new formula that goes with heat.
This is like a different language.
They're variables.
What does it stand for?
Get ready to tell you.
We write this down. I'm trying.
Q is heat absorbed or lost. It will be in joules or J. M is a sneaky one. What do you suppose M stands for? Yes.
I got it right. I'm so proud of myself.
Which is in grams. Now, CP is a new one. CP is one variable. Even though it has two letters, it's one variable. It stands for specific heat. Okay? Its unit is long. It's J over G degrees Celsius. Now, that degrees Celsius could just as easily be a K. It can be either one. Okay? Doesn't matter which one it is. I'm just going to leave it as degrees Celsius because this is the only formula that can be calculated in Celsius or Kelvin that we will do all semester long. Now, CP can be found on the reference table. If you need it and it's not given to you, you can find it on your reference table. I can't remember. I think it might have been Queen who got it confused with the density column because she looked at the wrong column on the last quiz we took last week. So it's on the reference table. All right, and delta T is change in temperature. Now, you should remember delta from math class. This is always the positive difference. So when you subtract the numbers, if you get a negative number, just get rid of it. It's just the positive difference. Okay? We don't need the negative number. Just get the positive difference.
Should have been our math teacher.
I mean, she's telling us we don't have to round.
Just
I
tell
mean,
you.
that's muscle memory for me. I have to run. It's kind of hard not to.
Then go ahead. I'm not telling you you can't. I'm just telling you I'm not teaching it.
Yeah. But I'm talking about all this stuff like delta T. We did not learn that at all.
He just started writing delta.
He just started cussing at us basically.
I can't fix that either.
You were
Good kids.
Huh?
You were good.
I shot her.
No.
Yeah.
He hot.
I miss Mr. Harris.
Oh, that man.
Yes, that was the.
Moving on. Everybody got what they need?
Yeah.
Okay.
Mario's still ready.
Who's still right?
Mario.
Oh,
Oh, Mario's gonna say something.
I didn't need it, but.
Yeah.
got it?
I was looking out for you, bro.
Yeah.
Instead of his hair up
You
here.
still got that, baby. Yeah.
When you used to make fun, Griff.
That's all right.
Good times, good times.
Oh.
Yeah, he was my best math teacher.
Stupid symbol.
Yeah.
That, him and Mr. George, Mrs. George.
They were the only competent.
Wait, what happened?
They're not dead. They're
Oh,
not dead.
oh,
They're just gone.
Yeah, Mr. Cross.
Whoa.
Well, he was easy.
Oh, I thought you said that he was like.
And that's the word.
Like
Yeah,
today. I thought the last day you were
Alright.
on Friday.
Yeah.
I'm ready for
Oh, yeah, I forgot, he's still teaching as well.
I really hope.
Yeah.
All of them did like they picked up.
I mean, I like him as a person.
She can give me stats, so. Have fun with that.
I wonder math.
Do you know who teaches me?
Probably Charlie. Yeah.
Figure
Like, I
that
don't
out.
understand. So like, he's just giving us a worksheet.
But they're better, I'll tell them you drive us north.
So basically,
I tried to get
yeah. I don't know, that was so,
We didn't even try.
we learned like 2 subjects in one day, every day.
Oh,
Right.
2 different
He
subjects.
did that for next week.
Oh,
All right, write this down. We need to work at least 2 of them before the bell. Everybody knows how to do it.
Yeah, you put it on the.
No.
I wish you have a set. Okay, because remember, you don't have anything to go back and study for the benchmark, for the test, or anything, unless your memory is really good and you'll remember this down the road.
I don't study.
So I always encourage you to have at least 1 sample.
That's not surprised.
That's why physical science is taking the test today instead of tomorrow, because my response was, well, we have a 3-day weekend. Yeah, and you're gonna study for the test? No, then we're taking it tomorrow. Or Tuesday. My physical science class does.
Oh, so it's
They're not gonna study for it anyways. Might as well take it today.
Ain't no benchmark coming out.
Well, we're only on day 6. Let's plan we don't have to take
I was planning for graduation
Like,
coming up.
We just got school. We took
it.
it on
It's usually around day 20.
Remember it?
It's done to hit me down with you.
It's usually around day 20.
Somebody asked me what grade I was in this morning, I was so worth they tell my no.
Like third week. I'm like, why we got a benchmark?
Yes, I never agree with where the benchmarks are, but I have no control over it.
I hate standardized testing.
I find it.
Yeah, I do
I
too.
don't have any control over that either.
Ridiculous.
Oh, I get
And then they
headaches.
have you come up with very kind of.
Yeah, not even headaches.
All right, so what are they asking us to find in the question?
How much?
All right, so is heat, based on what you have written in your notes, because I've minimized and gotten rid of that page. Is it Q? Is it M? Is it CP? Or is it delta T?
Q.
It's Q. How much heat, if it just says plain heat, is Q. If they want specific heat, it will say the words specific heat, okay? If it just says the word heat by itself, it's Q. Now, what's heat, or sorry, mass then?
15 grams.
15 grams.
Wait, so what's-
All right. CP, specific heat. Did they give us a specific heat up there in the question?
You gotta go to, no.
They didn't give it to us. Hold that thought. We'll come back to it in a minute, Tasha. All right, so we've got, what did you say, Tasha? If it's just heat, it's Q. If it's just heat, it's Q. All right, are you okay with mass being grams? Okay. So they didn't say anything about specific heat up here in the question, right? So we're gonna skip that one for a second. The degrees Celsius, what is degrees Celsius? That's what?
It's 45.
That is, which one of those variables up here?
No, it's delta T, delta T.
That's the temperature.
It will be.
Okay, Celsius is temperature. Can we agree on that?
Yeah.
So delta T is change in temperature. Change in means to do what?
To try.
Subtract. Okay? This means that you're going to subtract temperature. All right, so you're going to take the 67.5 and you're going to subtract the 45.1 to get the new temperature.
22.
So 22.4 degrees Celsius. Now, back to what Tyshawn was saying just a minute ago. Given that they did not give us a specific heat, it's not listed in the question. Anyway, where do we look up the specific heat?
Just blue sheet.
On the blue sheet. So in the question,
Column for iron.
what element did they give us? Iron. So find iron on your blue sheet.
0.449.
0.449. At the top of that column is the unit for iron. So what unit did they list at the top of the column for iron?
Celsius.
Joules over grams degrees Celsius. Now, the reason I had you write that down is you're going to need a unit for your Q. So what's going to happen to our G's? They cancel out. What happens to our Celsius? They cancel out. And so we're going to be left with what? Going to be left with a joule, just so you know your unit. All right, so our formula is what? Q equals M CP delta T. All right, what variable are we solving for? Okay, what's M?
15.
What's CP? 0.449. And what's delta T? 22.4. Now, this is a very easy one to solve for because all we have to do is what? Now, this is where all that crap we learned last week comes into effect. How many significant digits do I need in my answer?
2.
I'm going to become an alpaca farmer.
Right?
3.
Oh, it's a 0 up there.
I was wondering why you kept writing 15.0 down.
Oh, now it makes sense. We do have to write it down.
I always do that.
Yeah, so now.
I never do it.
So, when I round my answer off, I need how many significant digits?
3.
So, when I write this 150, I need to keep the what? The decimal, so that that 0 is what? Significant, or I could just round that 0 to a what? 151. Either one is fine. And then I need to put a J behind it for joules. Either answer is acceptable. But I need 3 significant digits in my answer. That is why we spent all that time with significant digits. So that now when we do word problems, our answers have the correct significant digits. Questions?
Yeah.
What?
See, I wasn't like worried about like the quiz, but now I am.
Why?
Because I said 2 instead of 3.
Oh, you forgot that 0?
Why did you cross the variable? I mean, the Celsius.
Because those are going to cancel out, so you know which unit you're left with in your answer.
Okay.
Probably not.
Okay, no.
Probably not.
And where you get the 4?
Where did I get the what? Go back. That was we found on the blue sheet for specific heat for iron on page 1.
Okay, that's.
All right, let's try this one. I don't think we have time necessarily to write it down and solve, so let's solve. All right, what are we solving for here?
Specifically.
All right, so which variable are we solving for if we're looking for what is specific heat?
CP.
All right, so we're solving for CP this time. I already said that. Way to catch up.
Good job.
All right, so what do we know?
Wait, let's start. It's
So-
15.
I told you we probably didn't have time to write this one.
The mass is.
All right, so the mass is 525.2. And what else do we know?
Q.
Q is what?
565.
See how it says joules right here? Joules goes where?
Jules goes at the end. Thank you.
565 with that J, or joules, is a Q. See how it says of heat also? Heat is always what? That's always joules or Q. All right, now, when you see your Celsius, what do you do with Celsius? You subtract. So 112.1 subtract 63.6, I get 48.5. All right, so if I plug in, and this is what I want to make sure I do for my folks who are math challenged. Q is 565.4, 525.2, CP, and 48.5. What should I do to solve for my CP, for my math folks who struggle?
Divide it by 525.2.
You can. I probably would not do that first.
Oh, you multiply those two numbers.
I would combine my like terms. I would go ahead and combine those. 525.2 times 48.5 and get my 25 for 72.2. CP equals 565.4. And now I'm going to divide and get my CP and divide here. Now, once I do that, I get point, and I probably divided that wrong. I got a really small number. Somebody check my math. Because I probably divided wrong.
0.02.
0.02?
1. Yeah.
I did it right. Now, what unit do I put on this?
No.
Joules over
It'd be
grams,
Celsius.
degrees Celsius.
Now, the reason I'm pointing this out is, let's say you get to the quiz or test later this week and you're like, oh my God, I don't remember the unit. Look at your blue sheet. Look at the top column above specific heat. If you should forget, and you're like, I don't remember the wall. Look at the top column. You can just write it down, because it's at the top of the specific heat column. And you can.
Oh, we can't use
Just don't write other crap on it. Otherwise, you get mine. All right, this half sheet of paper that I'm giving you is homework. Okay? All of the questions. It's only 6. I don't think 6 questions is asking too much. All right. Tomorrow we'll do physical and chemical properties, physical and chemical change, and we should, I hope, get to the lab before we get out of class tomorrow.
Okay, I forgot.